Welcome back to Arxflix. Today, we're diving into a fascinating research paper titled, "Are Emergent Abilities of Large Language Models a Mirage?" This paper poses an interesting alternative explanation to emergent abilities seen in large language models. This figure shows the claimed emergent abilities, where model performance shows sharp and unpredictable improvements at certain scales. Let's break down what the authors argue in their paper. Emergent abilities are defined as abilities present in larger models that are not seen in smaller models, appearing suddenly and unpredictably. This phenomenon raises crucial questions about AI safety and alignment, as these abilities could potentially lead to unintended consequences. The authors propose that these emergent abilities may not be fundamental changes in model behavior. Instead, they argue it's the researcher's choice of metric that creates these apparent sudden abilities. Nonlinear or discontinuous metrics can distort performance to appear sharp and unpredictable. This figure illustrates how different metrics can create apparent emergent abilities. Whether using nonlinear, discontinuous, or linear metrics like token edit distance, you can see the impact of the metric on the performance curve. The authors create a simple mathematical model to demonstrate their hypothesis. They assume that test loss falls smoothly and continuously with the number of model parameters, following neural scaling laws. Using this equation, they show how different metrics can transform this smooth, continuous decrease into sharp, unpredictable jumps in performance. The probability of a single token being correct increases smoothly with model size, but metrics requiring a sequence of correct tokens can amplify this into emergent abilities. When using metrics like accuracy for sequences, performance changes sharply and unpredictably, creating the illusion of emergent abilities. To test their hypothesis, the authors applied different metrics to the Instruct GPT-3 family for arithmetic tasks and analyzed the results. By switching from nonlinear metrics like accuracy to linear ones, they found smooth and predictable performance improvements. These figures show that under nonlinear metrics, performance appears emergent. However, using linear metrics like token edit distance reveals smooth improvements, supporting the author's alternative explanation. They conducted a meta-analysis on big bench metrics, revealing that over 92% of alleged emergent abilities appear under just two specific metrics. Changing the metric often made these emergent abilities disappear. Specifically, metrics like multiple choice grade and exact string match accounted for most emergent abilities. When switching to continuous metrics like Brier score, these emergent abilities often disappeared. To further demonstrate their point, the authors induced emergent abilities in vision tasks by changing the evaluation metrics in various deep networks. For example, they used nonlinear autoencoders and altered the reconstruction metric to induce apparent emergent abilities in image reconstruction. Similarly, they trained autoregressive transformers on omniglit characters and changed the classification metric, resulting in emergent abilities. This paper suggests that emergent abilities may not be a fundamental attribute of increasing model scale, but rather an artifact of metric choice. This revelation has significant implications for how we evaluate and interpret the abilities of large language models. The authors urge the community to carefully consider metric choice and its impact on evaluating model performance. This ensures we don't misinterpret the capabilities and risks associated with increasingly large models. That's all for today. If you found this summary insightful, please like and subscribe for more academic paper breakdowns. See you next time on Arxflix. Thanks a lot to Element for supporting Arxflix and providing this wonderful voice.